by mathematical induction that this statement is indeed true. All the result is indeed true, and in this case, because this is a positive contains of positive integers, then we can imply or we can invoke the proof by mathematical induction. And in order to ascertain whether the result indeed holds, then we assume one. We want to assume that indeed n equals to 1, or let n to be 1, because there is something that is missing here. For n greater than or equals to 1, then we assume that for n equals to 1, what do we have? Then let's set Pn to be equals to is equal to 1 plus 2 plus 3 plus all the way plus n, which equals to n into bracket n plus 1 over 2. Then what is P1? P1, when n equals to 1, then we have got a correct substitution, which is we have 1 here, then we also invoke 1, we add 1 over 2, which is equal to 1 over 2 divided by 2, because 1 plus 1 is 2, which gives us 1 multiplied by 1, which is 1. So P1, of course, equals to 1. Again, on the second instance, let us assume that n equals to k. Then we have to imply that if n equals to k, then pk equals to k into bracket k plus 1 over 2, which of course leads us to 1 plus 2 plus 3, then all the way plus k. Then members, let's see whether k plus 1 is true. Then we have p plus k plus 1 into bracket k plus 1, then we have got which is k plus 1 into bracket k plus 1 plus 1 plus 1 over 2 equals to 1 plus 2 plus 3 plus all the way to k plus 1, which is true that indeed the equation holds. It is true that 1 plus 2 plus 3 plus all the way to n plus n then equals to n into bracket this statement is equal to that one, which is true. That's proved by induction. Thank you for watching my channel Mathematical at 0H. Bye bye.